We're going to start today talking about chemical bonds. This video is just an intro, things that you should know already in order to prepare you for chemical bonding unit. So the first thing you need to remember is what an ion is. An ion is an atom or group of atoms that have a positive or negative charge. So far, all we've talked about is atoms that have a positive or a negative charge. But now we're throwing in this group of atoms. These group of atoms are things called polyatomic ions, which we'll talk about in a minute. But an ion is basically anything that has a charge, a positive or a negative charge. They'll form when an atom or a group of atoms lose electrons. If they lose electrons, they get a positive charge. They're called cations. Or when an atom or group of atoms gain electrons. If they gain electrons, they get a negative charge called an anion. So why are those positive and negative charges? If you've lost electrons, then now you have more protons, which are positive, than electrons. So you have a positive charge. You lost something negative. If you gained electrons, now you have more electrons than you have protons. You've gained something negative, so you're becoming even more. You're becoming negative, going from neutral to negative. So that brings us to monoatomic ions. That's all we've talked about in this class so far is monoatomic ions. These are ions consisting of only one atom. What does that mean? The things off the periodic table. The fact that sodium likes to lose an electron to become Na+, that's a monoatomic ion. It's one atom, sodium. One atom of oxygen if it becomes an O2-. When you have two of these monatomic ions that come together to form a bond, that's called a binary compound. Okay? And we can determine our charges off the periodic table. And we've talked about this already, and you should have labeled your periodic table. But just to review it very briefly, your metals love to become cations. They like positive charges. So for instance, group 1A, which is the same thing as group 1, which is the same thing as alkali metals. Those like a charge of +1. Group 2A, your alkaline earth metals, those like a charge of 2+, like to lose 2 electrons. Your boron group, they like to lose 3 electrons. Then you have your carbon group, that's group 4A or also group 14. They can either lose 4 electrons or gain 4 electrons. They tend to not want to do either, but those are their options. And you've got this labeled on your periodic table already. Now let's look at our nonmetals. Our nonmetals have like to gain electrons because they are very close to achieving an octet. So group 5A, which is your nitrogen group, has 5 valence electrons. It needs 3 more electrons to gain an octet, so it gets a charge of -3. Group 6A, your oxygen group, those get charges of -2. Group 7A gets charges of -1. Your noble gases, that's group 8A, they don't usually form ions because they don't like to react. They don't want to form bonds because they're already perfect the way they are with their octet. Because always, that's the goal we want, octet. Your group 4A, again, that carbon group that we talked about, that can either get a +4 or a -4, they usually tend not to do that. They prefer to share electrons, and we're going to get into that when we get to the covalent bonding unit. They tend not to want to form ions. Okay? So you should have labeled your periodic table already. And it's important that you have it labeled or you recognize where the charges are because it'll help you a lot in the future when we're putting together formulas. So for instance, this is what you should have labeled. At the very top of group 1, you should have written a +1, +2, +3, +4, -3, -2, -1. No charge for your noble gases. If you notice, this isn't colored. There's some funny stuff that happened with these guys, and we'll talk about that in a later time. Also, your transition metals, we don't have our charges marked there because they tend to be variable. There are 3 that are not variable that you will learn. We would have to tell you what the charges are, but they tend to form cations because they're metals. Metals like to be cations. Okay, to switch gears just slightly for 1 second, we're going to talk about our diatomic elements. These are not charged atoms. These are elements that just do not exist as a single atom. They don't want to be by themselves. They need a buddy at all times. And that buddy might look like a bond that's been formed between that atom and some other atom. But if they can't find somebody else to react with, to bond with, then they're going to bond with themselves. There are 7 of these. There is hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So it's shaped like a 7 on your periodic table, plus a 1, because hydrogen is always that oddball we talked about. Shaped like a 7, there's 7 of them, and then this one right here. Okay? These guys do not like to exist by themselves. So if hydrogen can't find somebody to bond with, it's going to go find another hydrogen and it's going to bond with that. If nitrogen can't find something else to bond with, it's going to go find a nitrogen and bond with that. If oxygen can't find something to bond with, it's going to find another oxygen and bond with that. They do not like to be by themselves. So if I were to say, what is the reaction between iron and oxygen? What you must write is Fe for iron plus O2, not oxygen, but it's not oxygen atom, O2. If I say the word oxygen, I mean O2. The only time these atoms exist by themselves, not connected to anything else, is when they turn into ions, when they get a charge. Then they can be by themselves because they got some electrons to keep them company. They got their octet. But otherwise, they're always going to be bonded to something. I would label that on your periodic table. Let me show you how. This is the periodic table that we've been working on all along. So we're going to continue labeling this because it really helps you remember things. So we said our diatomic, there are 7 of them. So I'm going to just outline the 7. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine. And little oddball hydrogen. Okay? That way it helps you remember. It helps you remember where your diatomics are. If you choose not to label because you think it looks too busy, you can write them like in the margin somewhere. But make sure you put it on your periodic table because you will be responsible to know them. In a typical year, you need to have them memorized. This is not a typical year. Okay, that brings us to back to ions, our polyatomic ions. This is a group of nonmetals, So we're looking at the orange stuff on the periodic table, top right-hand corner on the right side of the stair step on the right side of the metalloids. It's a group of nonmetals that work together as one unit. They exist bonded together, actually bonded together by something called a covalent bond. They're bonded together, but they also have a charge, making them an ion. They also carry a charge, making them an ion. There are many, many of them that you should be familiar with. If you look in your Schoology page, you will see a file that has your polyatomic ions. I think the file is either called Ions, Symbols, and Charges, or it's called PA and PT. PA for polyatomic and PT for periodic table. Okay, but these are some of the most common ones that you'll see. We have one polyatomic that is positive, 1, and that is the ammonium ion, NH4+. NH4+. That plus goes to the entire molecule, not to the hydrogen, goes to the entire molecule. So you can imagine parenthesis NH4, close parenthesis, and then the plus on the top half. That NH4, that ammonium, likes to stick together. So we treat it as one entity. It works as one thing. We can replace it with the letter X and treat it as one thing. Carbonate, CO3, that whole thing gets a charge of 2-. Your bicarbonate, HCO3 -1. Bicarbonate, if you throw sodium in front of it, you get sodium bicarbonate, which is your baking soda. We have nitrate, we have nitrite, sulfate. These are the more common ones you see. These are the 2 main ones that end in IDE, hydroxide and cyanide. But most, if you notice, most of your other polyatomics, with the exception of ammonium, which is its own thing, because it's only one positive, most of them end in ate and ite. So if you see a name that says ate or ite, then you know you're talking about a polyatomic, with the exception of these guys that end in IDE. Okay, so let's talk about our metallic ions. I told you your metals like to become cations. They like to be positively charged. They like to lose electrons. We're going to have an entire unit on naming formulas, naming compounds. But I'm just going to briefly mention this here, how to name your metallic and your non-metallic ions, because I'm going to be discussing them and you need to be able to recognize what I'm saying. So your metallic ions like to become cations. So if you were to name a metallic ion, a cation, what you do is you use the full name of the metal and then you just add the word ion to the end. So that's pretty easy. So if you're talking about calcium 2+, you're going to call that calcium, because that's the name of this guy, and you're going to add the word ion at the end, calcium ion. If I'm talking about Al3+, I'm going to call that aluminum ion. If I just say the word calcium, then I assume that I'm talking about just calcium, Ca, with no charge. If I'm talking about calcium ion, if I'm talking about the thing with the charge, I must say calcium ion. You must have that word ion if you're talking about just Ca2+. Okay? Our non-metallic ions, our anions, the nonmetals that form negative charge, they like to gain electrons. So if we were to name these, it's a little more complicated. It's not complicated, but it's a little bit more complicated. To name these, you're going to drop the end of the name of the element, and you're going to add IDE at the end. For instance, and then add the word ion. For instance, Cl-. Cl is chlorine. You're going to drop the end of chlorine. You're going to drop the INE, and you're going to replace it with IDE. So it becomes chloride ion. So let's try a couple more. Okay, let's try a couple more examples. So here's fluorine. F by itself is a fluorine atom. It's one of your diatomics, so it should be F2. But fluorine, this is a fluorine atom. If I were to name this, I want to name F-, so it's the fluorine atom with a negative charge, so it's gained an electron. I would knock off the end of the name and replace it with IDE. So this becomes fluoride. Okay, for oxygen, same thing. This is an O2-, so I would knock off the end and replace it with IDE. So this becomes oxide ion. I should say ion. Okay, down here, if we want to, this is nitrogen. If we're talking about N3-, we're going to knock off the end of the name and replace it with IDE. This is nitride ion. So now that we've set the foundation for bonding, let's talk about what an actual chemical bond is. Up until this point, all we've talked about is individual atoms off the periodic table. But as we know, they like to come together and react and form bonds. It's the reason we have water. Water is made up of two chemical bonds, an oxygen and two hydrogens attached to that oxygen. That's a chemical bond. Sodium chloride, which is a chemical bond between sodium and chlorine, gives you your table salt. What is it that motivates these atoms to come together? Well, that motivation has to be mutual, and it has to be something that's going to benefit both atoms. So in a chemical bond, there is a mutual electrical attraction between the nucleus of one atom and the valence electrons of a different atom. Your nucleus, which is positive, is pulling on those valence electrons of another atom that kind of floats on by. And that's what binds those atoms together. When a bond forms, the valence electrons are either shared amongst two atoms or they are transferred from one atom to another. If they are shared, that's called a covalent bond. If they are transferred, that is called an ionic bond. And we're going to talk about those individually in a minute. You can tell what type of bond is going to occur by looking at their electronegativities. The difference between those electronegativities can tell you whether you're going to make an ionic bond or a covalent bond, which are the two most important bonds that we discuss in this class. There are three types of bond, actually, that we discuss. The two most important are the ionic and covalent, but we also discuss metallic. Metallic bonding is the bond that holds atoms of a metal together. So if you have two metals, if they come close to each other and they bond, that's called a metallic bond. The fact that you can wear gold jewelry is due to metallic bonding, because gold jewelry isn't just one gold atom, it's multiple atoms of gold that are all bonded or held together to make gold that you can make into earrings. There is ionic bonding. Now, ionic bonding has the word ion in it, so that means it's going to have charged atoms. Okay, there is a complete transfer of electrons. One atom, the metal usually, will transfer its excess valence electrons to the non-metal to achieve an octet. Ionic bonding, that's the one we're going to spend a fair amount of time on today. Then there's covalent bonding, and that's where electrons are shared. It's not a transfer, it's a sharing. They're coming together to share electrons. And those covalent bonds can be divided up into what's called polar covalent bonds and non-polar covalent bonds. And we're going to discuss this in a later video. Okay, so I said that for any of these bonds to occur, there has to be a motivation. One of the biggest motivations is the octet rule. Okay, the octet rule says that your atoms want to lose or gain electrons in order to make them isoelectronic with a noble gas. What does that mean? Atoms want to have 8. They want to have 8 valence electrons. That's what they want. That's what makes them happy. And they're going to do what they can to achieve 8 valence electrons, which is what most of your noble gases have, except for helium. Helium only needs 2. Okay, so we're going to talk about electron dot structures, which we've discussed before, but I'm just going to show it to you again. Again, your electron dot structures are ways of representing the valence electrons in an atom. We only care about the valence electrons because those are the electrons that do the chemistry. All the other ones are not important because they're not the ones that do the chemistry. It's just a way of representing your valence electrons. So if you had some generic atom like X, and it had 1 valence electron, let's say it's an alkaline metal and it had 1 valence electron, you would just place 1 electron around it. Usually you show it as a dot. If you had 2 valence electrons, you would put 1 up here. Doesn't matter the order you put them in, as long as you do not pair up until you have to. 3 valence electrons, 4 valence electrons. Once you've filled up each corner, then you can start pairing up. 5, 6, 7, 8. This is the configuration of a noble gas. This is the configuration of a halogen. Your valence electrons are shown using your electron dot structure. So if you were to look at group 1, your alkaline metals, it has 1 valence electron. Group 2 has 2. Group 13, 3. Group 14, 4. 5, 6, 7, 8. These are your noble gases. This is your halogens. The electron dot structure for something in group 1 looks like this. For instance, lithium has 1 valence electron, so you see 1 dot. Beryllium has 2 valence electrons, so you see 2 dots. Boron has 3 valence electrons, so you see 3 dots. Notice how they are not paired up yet. Carbon has 4 valence electrons, so you see 4 dots. They're not paired up. Now we got to start pairing up. Here's nitrogen with its 5. We have 2 here, 3, 4, 5. This is called a lone pair of electrons. These are unpaired electrons. 6, 7, 8. So when we're talking about bonding, we need to know our valence electrons and we need to know their electron dot structure because it tells you a little bit how things move and how things mix in together. Okay, let's start talking about the first type of bond, and that is the metallic bond. This is the most boring of the bonds because it doesn't do much. We don't talk about it very much. But it is the bond between metals, metal plus metal. the bond between metals. The fact that you can build things out of iron is because you've got a lot of iron atoms bonded together via a metallic bond. They hold those metals together, and it's a very, very, very strong bond that has electrons that are described as a sea of electrons, because you can't tell who the electrons belong to. Once they're in this bond, they kind of move around everywhere, and you can't tell who they belong to. So some characteristics of your metallic bond. It's forms between metals. You have an electron cloud forms around these atoms. You have a sea of electrons. So you've got all these electrons, and we don't know who they belong to. They're all over the place. It's a metal, so they're good conductors at all states. That means if you have a metal as a solid, it's going to conduct. If you have a metal as a liquid, it will conduct. If you have a metal as a gas, which we don't on Earth, but let's say if we did, it would conduct. They're shiny, they're hot, they got very high melting and boiling points. That means it takes a really, really high temperature to go from a solid, which is what most of your metals are on the periodic table with the exception of mercury, to go from a solid to a liquid. Really, really high temperature, so it's hard to do it. Same thing with the boiling point. If you're already liquid, if you're molten, if you've melted, it takes a lot of heat for it to go from a liquid to a gas, which is why it doesn't happen here. Okay, they're ductile, they're malleable. Some examples of metals: sodium, iron, aluminum, gold, and cobalt. These are all different examples of metal. Aluminum, you make your aluminum cans out of that, right? So what does that look like? So this is what your sea of electrons looks like. Oops. This is what your sea of electrons looks like. Here are your nucleuses, and these are the electrons. You can't tell where one electron starts and the other one ends. In the next video, we will speak just about ionic bonding.